So we're going to look at the three different functions, or the three different models that we've talked about. We've talked about linear so far, which is a straight line. We've talked about exponential, where something's growing exponentially, which means it's getting larger and larger every time, or it's decreasing exponentially, which means it's getting smaller and smaller every time, either some sort of factor or a percentage. And then the last one that we talked about yesterday was quadratic models. So we want to just kind of understand the difference between the three. That way we can identify which is which. The first way that we'll probably see these functions will be their equations. And looking at the equations, it's pretty easy to tell the difference. Any of your linear functions either have an x with no exponent, or it doesn't even have an x at all. So anything that's linear, so we don't have an x there. Our x here has an exponent of 1, right? Exponent of 1, exponent of 1. Those are all our linear functions, and of course that's anything in our y equals mx plus b situation. Our exponentials, the x is in the exponent. So we can see y equals 3x plus 1, that x is a exponent. Y equals 5 to the 2x, that x is an exponent, and the x here in the 4 is in the exponent. So anytime we're looking at this, and remember that our basic equation was a times b to the x power, where the x is in the exponent, hence the exponential part of it. And the last one we just started talking about, which we mentioned in class yesterday, where our highest exponent is to the power of 2. So we have 2x squared plus 3x minus 5, and we have x squared plus 9, and I have x squared here. All of my x's, if they have an exponent, the highest they can possibly have is going to be a 2 in the exponent, and that makes them quadratic. So looking at the equations, it's pretty easy to tell which is which. The other thing that we can look at is their graphs. If we look at a linear equation, linear is a line, so we've got a straight line there. Obviously also we could have a straight line that is decreasing, but it is a straight line, and those are easy to see. Our exponential either rises or falls really quickly, so this one is falling really quickly and continuing that way. They could also rise really quickly. So those are our exponentials. So it starts in one direction and it continues in that direction. And then the quadratics, which we talked about today, are going to be our U's, so our smiley face or our sad face, or what we call our parabolas. So this one is a upward facing parabola. We could also have a downward facing parabola. But our parabolas let us know that we have a quadratic function. So those are the two easy ways. One of the harder ways is to look at their tables, and from their tables to understand it. The linear function, two big things. One, we never see the same value twice, and the y value, because it's constantly increasing or decreasing, so it never comes back. And the other one is the difference is the same for every single y value. So if they're increasing by 3, it's increasing by 3 every single time. If it's increasing by 5, it's increasing by 5 every time. If it's decreasing by 2, same thing. It's decreasing by 2 every single time. The exponential now is a little different. So y changes a lot more quickly. Again, you never see the same y value twice, but the big thing is this common ratio. So we have a common ratio. So we're multiplying each y value as they increase. Either multiplying by 2, or multiplying by 1/2, or multiplying by 4, or whatever it is. They're increasing by a factor or a common ratio instead of just the same difference. And then our quadratic. Most of the time with a quadratic, we will see the same y more than once. And the big thing we want to look at is the second difference. And the second difference is going to be the same. And I'll show you what that second difference is in a second here. But I want you to remember, quadratic, we see the same y, and the second difference is the same. So if we move on and look at these three tables. The first table, if I look at it, we can see these red lines. These red lines are telling us what's the difference in our y's. So the difference from -2 to 1 we are adding 3. From 1 to 4, we are adding 3. Adding 3, adding 3. So we can see here this one is going to be a linear. Notice our x's are increasing by 1, our y's are increasing by 3 every single time. So that one's going to be a linear. If we look at, we'll look at the bottom one first. So the bottom one, we're going from 0.8 to 0.4. We are multiplying by 5, which is our ratio. From 0.4 to 2, we're multiplying by 5. From 2 to 10, we're multiplying by 5. So we can see that we're multiplying and it's increasing very quickly. This one's going to be exponential. And we could call it growth because it's growing. Which leaves probably the middle one then is going to be our quadratic. So I want to show you what that second difference is. We can see the difference between -6 and -6 is 0. And the difference between -6 and -4 is 2. And the difference between -4 and 0 is 4. And the difference between 0 to 6 is 6. So we can see here that our difference is changing each time. Now, if I get rid of this real quick, and I erase these, we're going to look at the second difference of these numbers, because the first difference is changing each and every time. So we go from +0 to +2 to +4 to +6. Now if we look at the second difference for each of these, we're going to notice now here we have a pattern. So from 0 to 2, we're adding 2. From 2 to 4, we're adding 2. From 4 to 6, we're adding 2. Anytime that second difference is the same, we know we have a quadratic relationship.